Hey there, this is Dr. Rishi from the Learners Academy. How are you doing? I hope you are all doing well. So today, let us go ahead one step ahead into trigonometry. Today we are going to start talking about trigonometric identities. There are basically three trigonometric identities that we study in class 10th. The sin cos one, the tan and sec one, and the cot and cosec one. We are going to make three different videos dealing with each of these identities because these identities are very important when it comes to theoretical mathematics or mathematics which has a lot of proving mathematics which is used a lot in physics. So we would need these identities a lot. Specifically in your 11th and 12th, most of the sums would have these identities as their basic, and these identities would be used on and off at many such occasions. So without losing any time, let us start with the video. However, before we start with the video, let us go through the basics. There are 6 trigonometric ratios: sin, cos, tan, cot, sec, cosec. And today we are going to deal with an identity that involves sin and cos only. First we will see how this identity is derived. Then we are going to go ahead and solve few sums on this identity which have appeared in different boards. There are sums in ICSE, there are sums in CBSE, and there are sums in State Board. So we'll be doing 1 or 2 sums from each of these boards so that all the students can get an idea of how it all works. We would also be dealing with how we can manipulate these identities for our own advantage so that we can utilize this identity to our best. So without losing any time, let's go ahead. So we have a triangle ABC where angle A is theta and angle B is 90 degrees. Now let's go ahead and start with the very basic fundamental principle regarding a right angle triangle, that is the Pythagoras theorem. The Pythagoras theorem for this right angle triangle can be written as AB square plus BC square is equal to AC square. The sum of the squares of the two sides which are forming the right angle is equal to the sum of the square of the hypotenuse. So if I go ahead and I write dividing both sides by AC square, we get, so we are dividing by AC square, that is the hypotenuse square, we get AB square upon AC square plus BC square upon AC square is equal to AC square upon AC square. So that can be written as AB upon AC square plus BC upon AC square is equal to 1. Now if you consider this triangle, I can write sin theta as BC upon AC and cos theta as AB upon AC. So I can use these two in the place of AB upon AC here and BC upon AC here, giving me cos square theta plus sin square theta is equal to 1. This is our first identity. Now there is something very important that you need to understand when we are squaring the trigonometric functions. So these are called as trigonometric ratios or trigonometric. So this whole thing would be called as a trigonometric equation. So whenever we are dealing with a trigonometric ratio and we have to square it, we never put the square after theta. So if I have to write a trigonometric ratio and its square, I would always write it as, so if I have sine theta square, then it would be written as sine square theta. Why do we do it? It is something very important to understand. I cannot, and it is not equal to, this will never be equal, because if I use this, I would have to square the value of the angle. So suppose I have to have sine 30 square would be written as, however, if I had it as, it would effectively mean sine of 900. That is, the angle would get squared. Therefore, whenever we are squaring a trigonometric ratio, we are always going to put the square sign right after the ratio and not after theta. So this is our first identity that we have. Cos square theta plus sin square theta is equal to 1. It is by far one of the most important identities and is extensively used throughout mathematics and physics for standards 10th, 11th and 12th, and also after that. Now let us go ahead and see how we can manipulate this identity for our advantage and how we can see various forms of the same identity. Throughout my career, what I have experienced is that most of the students find it difficult when it comes to proving using trigonometric identities, and they find it difficult because it is difficult for them to imagine what all different forms this particular identity can take. So I would give you some forms that this identity can take, and then we would go ahead at solving some examples. Now, the identity that we had was cos square theta plus sin square theta is equal to 1. Now, this identity can also be written as cos square theta is equal to 1 minus sin square theta, or I can say cos theta multiplied by cos theta is equal to 1 minus sin theta multiplied by 1 plus sin theta, or I can say, now how did this come? It's a square minus b square. So by factorization, it would be a minus b multiplied by a plus b. So we will have, further we can simplify it and write cos theta divided by 1 minus sin theta is equal to 1 plus sin theta divided by cos theta. So both these forms can be used. This form particularly is very important when it comes to proving, which involves fractions. The other thing that we can prove from this directly is cos theta is equal to root of 1 minus sin square theta. Now in 10th standard, we are studying trigonometric ratios of acute angles only. That's why we are not involving a negative sign in this case. However, in your 11th and 12th, where you'd be studying all different angles, we would be making it as plus and minus of 1 minus sin square, root of 1 minus and 1 minus sin square theta. Now this was when I took sine on the other side. I can do exactly same with cos and get sin square theta is equal to 1 minus cos square theta, or I can write sin theta multiplied by sin theta is equal to 1 minus cos theta multiplied by 1 plus cos theta, or I can also write sin theta upon 1 minus cos theta is equal to 1 plus cos theta upon sin theta, or I can take square root directly and write sin theta is equal to root of 1 minus cos square theta. Now these are 8 forms of this particular identity, or these are 8 manipulations of this particular identity. If you keep them in your mind that this identity can be manipulated in these manners, and then we can use it to solve the proving problems, you'd find it slightly easier to understand or to finalize which identity to use. Okay. There is one more thing which is very essential to understand. It is important to know that if there is a proof and it has sin square theta and cos square theta, then we can equate it to 1. However, it is also important to keep in our mind that if we are proving a sum and it has a lone single 1 around there, we can replace that 1 by sin square theta plus cos square theta as well. Many students find it slightly difficult to figure it out what to do with that 1. So there are times in certain examples that 1 can straight away be replaced by sin square theta plus cos square theta, and it could take us to the answer very easily. Now let us go ahead and talk about certain sums which have appeared in standard 10th ICSE, standard 10th CBSE and standard 10th State Board. Now let us talk about this example. This is a solved example in a standard 10th ICSE Selina Concise book. Subquestion 1, example number 2. It is cos to the power of 4a minus sin to the power of 4a is equal to 2 cos square a minus 1. We have to prove this. So let's go ahead and see how we can prove this. Here we have cos to the power of 4a minus sin to the power of 4a on our left hand side, and we have to prove that it is equal to 2 cos square a minus 1. Now there are, as I have told you prior to this, there are two ways of proving it. We can start with the right hand side or we can start with left hand side. Personally, I favor to start with left hand side and go to the right hand side. So first I write my my left hand side. My left hand side says cos to the power of 4a minus sin to the power of 4a. So this can be written as cos to the power of 2a square minus sin to the power of 2a square. This would give me a square minus b square, so I can elaborate it or I can expand it using that identity and write it as cos square a minus sin square a multiplied by cos square a plus sin square a. Now this particular thing is in our identity. I'll write the identity that we are concerned about today here, that is cos square a plus sin square a is equal to 1. So this is equal to 1, so I can say that this is equal to cos square a minus sin square a. I will write a reason here because cos square a plus sin square a is equal to 1. Now I needed my cos to be there, so cos I will retain and I will change sin. Now what have we studied prior to this? That I can also write this identity as sin square a is equal to 1 minus cos square a, and I can replace it giving me cos square a minus 1 minus cos square a. Now the reason I will write here is because sin square a is equal to 1 minus cos square a. Now when I open this bracket, this one would get a negative sign and this cos square a would get a positive sign, giving me cos square a minus 1 plus cos square a, or 2 cos square a minus 1, which is equal to my right hand side. And hence I have proved this equation in a very simplistic manner, in a very straightforward manner. Now let us go ahead and talk about one more example. This is from exercise 21A from Selina Concise maths book for ICSE. It is question number 24, which says 1 upon 1 minus sin a plus 1 upon 1 plus sin a is equal to 2 sec square a. Now the example tells us that 1 upon 1 minus sin a plus 1 upon 1 plus sin a is equal to 2 sec square a. Whenever we are dealing with such a kind of example, where on the left hand side I have sine ratios and on the right hand side I have a sec, which effectively means that I have to make sure that I am equating my left hand side in such a way that I would get a cos ratio on the denominator side, because if cos is there on the denominator, it would directly get converted into a sec. So the first thing that I would need to emphasize while solving this particular example is to make sure that my denominator becomes a multiple of cos. Then only I can go ahead and make the required changes so that I can get a sec square a on the other side. Without losing any time, let us start with this particular example. So my LHS left hand side is equal to 1 upon 1 minus sin a plus 1 upon 1 plus sin a. Now since their denominators are not same, I will have to cross multiply them. So this gets multiplied by 1 plus sin a, and this 1 gets multiplied by 1 minus sin a, and the whole thing would have a common denominator, that is 1 minus sin a times 1 plus sin a, which would further give me 1 plus sin a plus 1 minus sin a divided by, now this is in the form of a minus b multiplied by a plus b, so I can straight away write it as 1 minus sin square a. So giving me, now this sin a would get cancelled with this sin a because they have negative signs, and these 1 and 1 would get added. So I have 2 upon 1 minus sin square a. However, what have we studied when we manipulated our first identity? We studied that 1 minus sin square is equal to cos square a. So that gives me my answer. It is 2 upon cos square a. So the reason would be cos square a is equal to 1 minus sin square a, and further I can write it as 2 sec square a. The reason being sec a is equal to 1 upon cos a, and this is my right hand side. So I can say that it is equal to RHS, and the proof is solved. Now let us take one more sum from the NCERT book which deals with similar identities. This sum is from exercise 8.4 NCERT book, question number 5, subquestion 7. It is sin theta minus 2 sin cube theta upon 2 cos cube theta minus sin theta is equal to tan. We have to prove this. This is a very interesting sum, and many of my students have had a doubt in solving this particular sum. So let us see how we can solve this. Now the sum says sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta is equal to tan theta. If you see on the left hand side, we have only sine and cos ratios. On the right hand side, we have tan theta, just a single tan theta. Tan theta can also be written as sine theta upon cos theta. So that is what we are going to aim for. We are going to make sure that the numerator is equated to sine theta and the denominator is equated to cos theta. So let us see how we can do it. My left hand side is equal to sine theta minus 2 sine cube theta upon 2 cos cube theta minus cos theta. Now it is common in them, so sine theta is common, I can write sine theta. So my numerator is sine theta times 1 minus 2 sine square theta upon cos theta times 2 cos square theta minus 1. Now if you look at it, I have got a sine theta and a cos theta. This part here would be equal to tan theta. So effectively I have to cancel these two out. How can I cancel them out? By equating them. While discussing this identity, I had told you that it is important for you to know where to replace sine square theta plus cos square theta is equal by 1, and it is also equally important to know where to replace 1 by a sine square theta plus cos square theta. This is one such an example. So I can write this one, I can replace it by cos square theta plus sine square theta, and I would get sine theta times cos square theta plus sine square theta minus 2 sine square theta upon cos theta times 2 cos square theta minus cos square theta plus sine square theta. So effectively I have replaced both these ones by cos square theta plus sine square theta, giving me sine theta times, now here I would get cos square theta minus sine square theta, because it's sine square theta minus 2 sine square theta, so I'd be left with 1 minus sine square theta or minus 1 sine square theta, and I will get cos theta times 2 cos square theta minus cos square theta minus sine square theta. So effectively I have sine theta times cos square theta minus sine square theta divided by cos theta times cos square theta minus sine square theta. So you can see we can cancel out these two as they are the same terms, and we are left with sine theta upon cos theta, which would be equal to tan theta, which is my RHS, and hence we have proved this sum as well. Now let us go ahead and talk about one sum from the State Board book. This example is from the State Board, the Maharashtra State Board book, practice set 6.1, question 6, subquestion 3. It says root of 1 minus sine theta upon 1 plus sine theta is equal to sec theta minus tan theta. So let us see how we can solve this sum. Now in this particular sum, we have a root sign on our LHS and we don't have a root sign on our RHS, which basically indicates that whatever is there inside the root sign, we need to make it a perfect square and then we can go ahead. That is the first thing that I have to do. The second thing that I have to do is, on my left, I have to check what is there on my left hand side and what is there on my right hand side. On my left hand side, I have only sines and sines. On the right hand side, I have sec and tan. Now what is common for both sec and tan? So they have cos theta on their denominator. Sec theta is 1 upon cos theta and tan theta is sin theta upon cos theta. So that indicates to one single thing, that is my denominator on the LHS should be a cos theta. Now how can I get it? How can I make a how can I get it as a cos theta using sine? So I can easily get it by making it into 1 minus sine square theta. So this is the first thing that I'm going to try and do. So I have my LHS as root of 1 minus sine theta upon 1 plus sine theta. So I will have to multiply the numerator and the denominator by trigonometric function so that it would become 1 minus sine square theta. So I'll multiply it by 1 minus sine theta multiplied by 1 minus sine theta divided by 1 plus sine theta multiplied by 1 minus sine theta. So effectively I have multiplied both the numerator and the denominator by 1 minus sine theta. It would give me root of 1 minus sine theta square divided by 1 minus sine square theta, because I am using the identity a plus b multiplied by a minus b is equal to a square minus b square. So square of this minus square of this. This further can be written as 1 minus sine theta square upon cos square theta. Why? Because as I have manipulated cos square theta is equal to 1 minus sine square theta. Now this further I can write it as 1 minus sine theta upon cos theta, the whole thing square. Now I can cancel the square and the square root and write it as it's equal to 1 minus sine theta upon cos theta, or that is equal to 1 upon cos theta minus sine theta upon cos theta. But 1 upon cos theta is sec theta and sine upon cos theta is tan theta, which is equal to my RHS. So I have ended up proving that the root of this particular equation or this particular function is equal to this particular function. That was it from my end today. So today we have studied the first identity that we study in trigonometry, that is sine square theta plus cos square theta is equal to 1, or cos square theta plus sine square theta is equal to 1. Please share and subscribe our channel. I know there are a lot of students out there who are struggling with trigonometry. I am trying my best to help them out. In case you have any queries, you can put it in the comment section. You can take a photo of it and send it directly to us on our Instagram or on our Instagram handle or our Facebook. You can also visit the academy and discuss trigonometry one-on-one. All the required details are given in the description. Please hit the like button, share this video and subscribe our channel. This was Dr. Rishi from the Learners Academy. Thank you.